So this is just a simple sketch of a Vernier caliper. So let us just name a few parts of this Vernier caliper. So this first part here, this one, is referred to as the main scale. This part here, the sliding part, is referred to as the Vernier scale. So this part here is referred to as the outside jaws. This part here is always referred to as the fixed jaw. It is fixed. And then this part here is referred to as the inside jaw. So it's important for you to take note that this instrument here, it measures its length in unit called centimeters. Make sure you take note of that, because a lot of people get confused and write their answers in millimeter, but instead it's supposed to be in centimeters. Now, let's say, for example, you have a test tube. Where do you think you're supposed to place it? Remember, this inside jaw is used to measure inside diameters, and this outside jaws is used to measure the outside diameters. So you can use this inside jaw to measure internal diameters and the outside jaws to measure the external diameters. So this sliding jaw carries the Vernier scale, as you said. And it's important to take note that the Vernier scale usually has a length of 0.9 centimeters. So if you measure the length from this point to this point, then this length is exactly 0.9 centimeters. And remember, this Vernier scale has 10 equal divisions. So if 10 divisions is equals to 0.9 centimeters, what about 1 division? So it is like 1 multiplied by 0.9, then you divide by 10. So 1 division is equal to 0.09 centimeters. So that is equivalent of 1 division. So when you talk about 1 division, is like the length from this part to this part on the Vernier scale. Remember, we're not talking about this main scale. These lines here on top represents the main scale, and these ones on the bottom represents the Vernier scale. That's why I've differentiated them by using the red color. So the distance from this part to this part on the red scale is exactly 0.09 centimeters. Now, what do you think will be the length of the main scale division? Let's say the distance from here to here. Now remember, these ones are exactly how they're supposed to be. So the distance from this point to this point is exactly 0.1 centimeters. So the difference between the main scale division, which is 0.1, then you minus by the Vernier scale division, which is 0.9. Remember, these ones are in centimeters. The difference between them you'll get is 0.01 centimeters. And now this one is now referred to as the least count. So in simple terms, least count is the difference in length between the main scale division and the Vernier scale division. So the main scale division here is 0.1. The Vernier scale division here, as we calculated here, is exactly 0.09. So the difference between the two gives you the least count, and that's how you define least count. Now, having known all that, let us now see on how we can use this instrument to measure length or diameters of objects. So let me clear this. Now remember, we said we always use these jaws to measure the diameters. So let's say we use the outside jaw to measure external diameters, and for you to measure it, you just need to place the thing you need to measure here, and then you just move this Vernier scale until it touches this part. And remember, this fixed jaw is also supposed to touch this part. Now you're supposed to measure this diameter. How are we supposed to use this instrument? Or what are some of the rules that you're supposed to follow for you to be able to measure the lengths of these objects you want to measure using this Vernier caliper? In your exams, you'll see something like this. It will be something like this, and then on top, so let me represent it with a white color. So on top, you'll have a scale like this, and then on the bottom, you'll also have a scale. So let me use red. bottom will also have a scale like this. So in exams, they'll mostly represent the question like this to represent this Vernier's caliper. Now, how are you supposed to interpret this? So this one basically shows that on top, this top scale here represents the main scale, and on the bottom here, this scale here represents the Vernier scale. So this is the main scale, this scale here that runs from this point to this point, and this down here is the Vernier scale, the scale that runs from this point to this point. Now combined, you can be able to calculate the length of any object or the diameter of any object. Now how are we supposed to know the length of this? So I can just give you a clear example of a representation of a question. So our first example will look like this. Now let us say, for example, this is our example here, and we want to measure, let's say, the diameter of this object. Remember, after, let's say, for example, we've placed our object, this is the final reading, this is the main scale, the one on top, this one here, and this is the main scale, and down here, this is the Vernier scale. Now how are we supposed to calculate this? So let us start with, remember we have two scales, so we need to know the distance or the length of the two scales, and then we add them together. So let us do that. So let us start with the main scale. Now how can you be able to read the values of the main scale? So for you to be able to know the length of the main scale, what we normally do is we always look at the value that is immediately behind the 0 mark of the Vernier scale. So this is the value of the Vernier scale here, the 0. So you need to look at the value that is immediately behind it. So this is 2, this one will be 2.1, and this value here that we want will be 2.2. So the main scale is exactly 2.2. So you can write it, well, this is 2.2. And remember, as we said before, the unit is in centimeters. That's it. We are done with the main scale. Now, how can you be able to know the value of the Vernier scale? Now, for you to be able to know the value of the Vernier scale, what we normally do is we look at the line to which the Vernier scale has exactly coincide with the main scale. For example, this one here, it has not coincide with the top line on the main scale, so this one is a no. This one also, it has not coincided, so this one is a no. This one here also has not coincided, this one is a no. This one here has not also coincided, this one is a no. But this one here, it has coincided exactly with the main scale, so this one is a yes, because if you look keenly, this line here and this line here, it's like a continuous line, meaning it has coincided. And remember, we always look at the first line that coincides with the main scale, not the second one or the third one. We always look at the first line that coincides with the main scale, and this is the line that we're looking for. So remember, we'll take the value of the Vernier scale only, and this value here is 4, because here is 0, 1, 2, 3, 4. So this value is 4. So you can write the Vernier scale is equal to 4. Now, remember, we are not done yet, because in Vernier scale, we do not take the value directly and then add it together with the main scale. So what we normally do is we take the Vernier scale and then we multiply it with the least count. Remember, previously we talked about the least count, whereby we said the least count is the difference between the length between the main scale division and the Vernier scale division. So that is like the smallest unit of measurement of a Vernier's caliper, and we calculated it and found out that the least count is equal to 0.01 centimeters. So for you to be able to calculate the Vernier scale, you need to take this value and then multiply it with the least count, because that is the values on the decimal places from the main values. So this is the main values, and this will be the value of the decimal places. So you can calculate that, whereby we will take this value here, this 4, and multiply it by the least count, which is 0.01, and this now will be in centimeters. So if you calculate this, you'll get a value of 0.04 centimeters. Now the final answer of this will be, you take these two and add them together. So the vernier scale, the main scale was 2.2 centimeters and the vernier scale is 0.04 centimeters. When you add them together, you'll find a value which is exactly 2.24 centimeters, and that is how we calculate the diameter using a vernier caliper. And I can just give another example. You can do another example, the final example, and then I'll give you one. You try it for yourself. So let me clear all this so that I can draw the next example. So this one will be example 2. So this is example 2. So now let us say, for example, you want to measure the diameter of the vernier caliper, and this is the value that you've gotten. Now, how can you be able to calculate this? For you to calculate this, we have two scales. So we have the main scale and we have the vernier scale. So let us start with the main scale. The main scale is this scale on top here, and the vernier scale is this scale on the bottom here. So what is the main scale? How can you be able to calculate the main scale? So the main scale, we say that we always look at the value that is immediately behind 0 on the vernier scale. So this is the vernier scale and this is the 0 value. So we will look at this value behind it here. So the value behind it is 0. So you can write the main scale as 0 centimeters. What about the vernier scale? The vernier scale, we say that we look at the value that coincide exactly with the main scale. So if you look at this value is not coinciding. So this is a no. This value is also not coinciding. So this is a no. This one is not coinciding. This is a no. This value is coinciding. So this is a yes. So what value is this? This is 0, 1, 2, 3. So the value that coincides with the vernier scale is exactly 3. And we say that in vernier scale, we take the value that you've gotten and multiply it with the least count. And the least count is exactly 0.01 centimeters. So the value of the vernier scale is 3. So we'll take this 3 and multiply it with the value of the least count, which is 0.01, and you'll get a value of 0.03 centimeters. So now you need to take the vernier scale and then you add with the main scale. So it will be 0 plus 0.03. Now remember, the unit for this is in centimeters, and you find your answer as 0.03 centimeters. And this is your answer. So you can try out this question and then leave your answer in the comment below so that we know if you have understood or not. So now let us talk about something called the zero error in vernier caliper. So we always have two types of zero errors, one of which is the positive zero error, and we also have the negative zero error. So a lot of students get confused between these two. They don't know which is which, and here I will exactly show you the real example, the real difference between these two. So what is the difference between the positive zero error and negative zero error? Or first of all, before we go to all that, what is actually a zero error? What do you understand by a zero error? So one thing that you're supposed to know, that it is very important that whenever the jaws of a vernier calipers are closed, let's say this vernier scale is completely shut down, whereby this part and this part touch each other. So what's supposed to happen is that the zero mark on the vernier scale, this zero mark here, is supposed to coincide with the zero mark on the main scale. So if there's an issue somewhere, or let's say the zero mark of the vernier scale does not coincide with the zero mark on the main scale, then that means that there's a zero error somewhere. So basically what is supposed to happen is this: whenever you shut down this instrument, and let us say, for example, this is our common line, then the zero mark on the main scale, this zero mark is supposed to coincide with the zero mark on the vernier scale here. And the other values will follow like that. So they're supposed to align with each other like this. So if there's a situation whereby this 0 mark does not coincide, let's say for example it is in front or back, then that is where the 0 error occurs. So 0 error occurs only when the 0 mark of the main scale does not coincide with the 0 mark of the vernier scale. So which is the positive 0 error and which is the negative 0 error? That is the question that you're supposed to ask yourself. So let us take an example of the vernier scale, for example, for us to understand this. So if the vernier scale is behind the 0 mark, then that will be a negative 0 error. So a negative 0 error is whereby the vernier scale is behind the 0 mark. So we take this one as the common point. So if the vernier scale is behind, then that is a negative 0 error, this one here. And if it is in front, in case if it is in front, let us use another color. If it is in front like this, then this is a positive 0 error, and this one is here on top. So if it is behind, then that is a negative 0 error. If it is in front, then that is a positive 0 error. So we can give an example, a diagram example of a 0 error, and then we calculate the 0 error. So let me draw it down here. So this is our main scale, and now let us draw the vernier scale down here, and this is our vernier scale. So if you look closely, our vernier scale is right in front of the 0 mark of the main scale, so it is in front. And you say that if it is in front, then that is a positive 0 error. So it is very important to take note that a positive 0 error, like for example this one here, this is a positive 0 error because the 0 mark of the vernier scale is right in front of the 0 mark of the main scale. So this value always gives a value that is higher than the actual value. Let's say for example you are trying to measure this diameter here, you'll get a value that is more than the actual value. So it is very important to always check that your vernier caliper does not have a 0 error before measurement, because if you do your measurement and the vernier caliper has a 0 error and you did not take note of that, then you'll find a value that is either higher or lower than the expected value. So a positive 0 error, like this one here, the value is always higher than the actual value. A negative 0 error, the one that the vernier scale is right behind the 0 mark of the main scale, the value will always be lower than the actual value. Whenever you are given a vernier caliper and then you're told that that vernier caliper has a 0 error of, let's say, something, so the actual value that you'll find after measurement, you're supposed to subtract it. If it's a positive 0 error, you're supposed to subtract that 0 error to the readings that you'll find. If it's a negative 0 error, then you're supposed to add that value. So it's like the opposite. If it's a negative 0 error, you're supposed to add it. If it's a positive 0 error, you're supposed to subtract it. It's like you're doing the opposite of the actual value given. If it's positive, you minus. If it's negative, you add. That is the simplest formula of knowing this. So let us look at this example here. So let us try to calculate the 0 error here. So what do you think is the 0 error in this measurement? So the main scale here is 0.2, because this is 1, this is 1, this is 2. So the main scale is 0.2 centimeters. What about the vernier scale? So the vernier scale, we always look at where it coincides. So where does it coincide? So it coincides here. Here is where it coincides. So it coincides at exactly 9. So the vernier scale is 9. And we say that the vernier scale, we usually multiply it with the least count, and the least count is 0.01. So if you do that, you'll get 0.09 in the vernier scale, Then you take that value and then add it to the main scale, which is 0.2, and you find your answer as 0.29. So this is the zero error. And remember, you're supposed to indicate whether if it is positive or negative. So in this case, because it is right in front of the zero mark of the main scale, then that is a positive zero error. So if you do your measurements, your final answer, you're supposed to minus this value because it's a positive zero error. So you're supposed to less the value of the zero error. It is very important to take note of that. Now let us look at the next scenario of a negative zero error. So this is a very good example of a negative zero error, whereby, as you can see, the vernier scale is behind the zero mark of the main scale. So what is the value of this zero error? So we just need to look at the main scale. So the main scale is obviously 0 because it is way behind 0. And then the vernier scale, we just look at the value that coincides exactly at the main scale. So this one does not coincide, this one does not coincide, this one no, this one no, this one yes. I want you to take note that even this value coincides with the 0 mark, I mean the main scale, but you're not going to use it because it is way in front of this one. So we usually take the first value that coincides with the main scale. So it's very important to always start from this point going this way whenever you are reading the vernier scale. Take note of that. So we'll take this value, and this value is exactly 1, 0, 1, 2, 3, 4. So the vernier scale is exactly 4. So we said under the vernier scale, we usually multiply it with the least count. The least count is usually 0.01 in a vernier caliper. So this 0.01, we multiply it with the value that you've gotten, which is 4, this one, and then you'll get exactly 0.04 centimeters. So this is a negative zero error. So you need to indicate it by writing here a negative. So this, your answer is negative 0.04 centimeters. So this is the zero error. So when you do your measurements and you find your final answer, you need to add it with this one, because a negative zero error usually gives you a value that is less than the actual value. So you are supposed to add this value so that you find the correct, accurate answer. Always take note of that.